recording. So Marc, you need to unmute yourself. You're still muted, Marc. So just need to click on your there is a microphone somewhere.
Opheffen, zei hij. Okay. Now, do you hear me now?
Yes, now we can hear you. Perfect. Good. The floor is yours. Thank you.
Okay. Do you hear me now?
Yes, and I can see your screen as well.
Okay, thank you very much for attending. My name is Marc Dendooven, call sign Dendo on the web, and I want to talk today about programming the Commodore 64 from scratch. That's the name of the project I am doing. Are you seeing my slides for the moment?
Yes, I can see your screen. Yes, your slides.
Your slides. Okay. Well, since it's the first time I'm attending here, I'm going to present myself. I'm a retired officer of the Belgian Army. I'm an engineer. I attended the Polytechnic department of the Royal Military Academy, and I did a master after master in applied computer science in the VUB, the Free University of Brussels. And my last job in the military was instructor in computer science. I have a Commodore 64 since 1983. And well, it was really the beginning. I think the first was in 1982, just it was all new. I had a cassette recorder. Only a year later, I had a floppy drive. I had just BASIC. And when I wanted to use machine code, I had to translate it by hand. So now that I'm retired, I started to make programs and things with the Commodore 64 again. And what I want to do in this project here is building an environment for the Commodore 64 without existing tools. So just like it is in 1983, I'm programming just in BASIC. If I'm using machine code, I want to do it by hand. And if I want to use other tools, well, I have to make them myself. That's the project. I don't know where I'm going to, what I'm going to reach, but I started with building a compiler. A good 25 years ago, I read the book, the very good book, Compiler Construction of Niklaus Wirth, the maker of Pascal. And some 10 years ago, I started to make a PL0, Programming Language 0 compiler in Pascal, and a little bit later, a very, very small Pascal compiler, also in Pascal on a PC. For those interested, I added there the GitHub addresses where that is. Yes, I had fun with that, but no, for the Commodore 64, I wanted to do the same. In fact, I wanted to make a Programming Language 0 compiler for the Commodore 64 in BASIC. But of course, there are some problems. BASIC is not structured. It's not very verbose. And when you have to write a program which is a little bit complicated, like a compiler, well, you have to have those things. Variable names are also a problem. We have only two significant letters for a variable. We don't give a name to a subroutine, so that's very difficult. And of course, the compiler, like Wirth proposed, it's recursive. And it uses local variables, but we don't have any local variables in BASIC. So I thought to do it another way, but no, I don't want to give up. I thought about it, and it is very good possible to do it. After all, structure, it's not because BASIC is not a structured language, we can work structured. The only thing we have to do is have some discipline to keep the structure in it. Verbose, well, we have to comment. Variable names, well, make a list, make a pen and paper, and you can make a list with all the variables you use. Well, it works. Same thing for the line numbers. Also for the subroutines, well, use a comment. If you call something, add a comment what you're doing. Recursion is also not really a problem, because the Go sub can handle 15 to 20 levels when you're not using much things on the machine stack. So it's doable. The only thing that was left was local variables. So what do? We put them on the stack. So what I did was making a stack in BASIC with two procedures, two subroutines. One, put a value on the stack. Second, pop it back from the stack. And in fact, that's all I need to make this compiler in BASIC. I made myself things easy, and I did no file I/O. I put the code to be compiled, so the PL0 code, and the basic code from the compiler in one file. How did I do that? Well, in my editor, in the basic editor, all in front is PL0, and that give me and all after line 4000, excuse me, before line 4000 it's PL0, after line 4000 it's my basic compiler. So I can very fast try things out and debug. I don't have to save a file, load a file, and I can very fast change some PL0 code, try it out, and yes, debug my compiler and change the things in my PL0 program. How did I do that? Well, I will show you in my demo, but I start every line from the PL0 section. I just started with a double quote. So the editor won't think it's a basic statement. It will think it's a string, and so it will not be tokenized. So I can simply read it and use it. Well, that's what I did for the moment. What will I do in the future? Well, first of all, cleaning up the code, because on the end, I was changing some little things. And even though I made it very structured, after I came to change things, well, hello spaghetti. So I have to clean up a little bit the code. I also want to write a text or a course or something from how did I make this compiler, a little bit introduction about languages, things like that. Then I will extend PL0, the compiler in BASIC, to write PL0 in itself. When I write PL0 in itself, I can go bootstrapping the thing, and it will be very more easy to extend it. I also want to make it faster, because for the moment it is very, very slow, because the compiler is in BASIC, but it doesn't compile to machine code. It compiles to a virtual machine. So it compiles to P code, and the P code is interpreted by a virtual machine written in BASIC. So it's not fast. The first solution would be to translate by hand the virtual machine to machine code. It's not that difficult to do. A better solution would maybe be to change my compiler to generate machine code, 6502 machine code in the place of P code. And another possibility would be to write a second compiler, a very small compiler, who would compile P code to machine code. But that's future. Then when I have something like that, I will extend again PL0 to write other tools. I can make an editor, make an assembler, and then I can also try to port it to other small systems that can be other old computers, or that can be small microcontrollers like Arduino or something like that. So that's what I intend to do in the future. Why want I do that? Well, there are a lot of people who say, why are you losing your time with the Commodore? Well, because it's fun. I like to do that. It's also something I wanted to do. I want to write that compiler, and well, I only change the platform. If I do that on a PC or I do that on the Commodore, it's, well, I like more to do it on the Commodore. It combines my hobby and my former job, and also I want to learn new things, and hopefully are people enough interested to so that I can teach them something new. Well, that's my day. That's my presentation. You have also the address and hitcap of the code. This will maybe change place because if I do a more general project with, like I said, the more tools, and maybe I will change it place. I don't know yet, but for the moment you can find my code there. And now I will do a small demonstration. Okay, I think I'm back on the screen now.
Yes, indeed.
Okay, and now I will, well, I will not show you what I did on the Commodore 64 because it will be too slow and I only have 3 minutes left, I think so. So in fact, I have my code here in an editor, and I will use the, how is it named? The CBM Basic to execute it, but it's exactly the same what happens on the Commodore 64. So for starters, on the first line, I'm go to 4000, where my compiler begins. And like I said, my PL0 program is here starting with a quote. So it's not tokenified. It's just there, and it can be read from my compiler. I will, for demonstration, I will delete the comma, a semicolon, I'm sorry. And I will use CBM Basic, and hop, here we are. It's exactly the same what would happen on the 64. And we have here our program is compiled, and he stops with, well, I deleted the semicolon, so the semicolon is expected, but begin is found. Okay, I will place it back, but I don't see much here because the light has become darker. I place, yes, the semicolon back, and I will again compile it, interpret it, I'm sorry, with CBM Basic, voila. What do I have here? I have the code which is compiled. It is compiled for the P code interpreter. So you see here the P code which is generated, and then the execution of the program. So what does my program? In fact, it will just doing a loop from 0 to max to 10, and it will each time call a subroutine who will display the number and the quadrat, the square of the number. So 0, 0, 1, 1, 4, 16, 5, 25, and that's it. So it's a little short, but I think it's in the time frame. If there are any questions, please go ahead.
Many thanks, Marc. Really, really nice indeed. I like what you said about the why. First reason is because it's fun. I think that's the main reason why we are all here, right? We do the
Well,
same.
yes.
We do things
It's our
because
hobby.
it's fun. But no, I think it's really impressive. I don't know if there are questions I don't see in the. Let me see in the chat on the Facebook page. No. Maybe I have one before the others in the call. I don't know. So you explained that okay, you do from you don't compile directly in machine code. You do
In P
go
code.
through this virtual machine and the P code. But then you said yes, with your just-in-time compiler that would go to P code and then to machine code. But then that would be even longer, right? So do you have any mean to compute the time that it takes, like for example, interpretation of the code that was executed there, and to compare it with what would be the result if it would be with
Well,
this extra step?
the program you've seen when I executed in the 64, well, the compilation and the execution, well, it's I think 20 to 30 seconds now for the little program now. If you have time, I can show it. But for the, as I say, I will change the virtual machine into machine code. I don't know. I didn't do it yet, so I have to see it the moment I do it. I have not a clue.
Okay.
I don't know. Are you interested to see it on the Commodore?
If you can, yeah, I think we can take a little bit of extra time to look at.
Okay, then I will. So my program is here. I will start Vice. Hello, Vice, where are you? Yes, there is Vice. And now I will inject it in Vice. Voila, no, it's compiling. Almost there.
And there you're running it with the, let's say, the real speed. It's not with.
That is with the virtual machine. Well, that's the code generated, and now the virtual machine is starting up.
Okay.
And you see it's slow. But of course, it's an interpreter written in an interpreter.
Yeah, exactly.
Of
I
course,
think it's still okay.
Very good to try out, because when I generate machine code and I make an error, well, the Commodore crashes. Here, when I make an error, well, it's basic. So it will give me an error and I can work with it. So in fact, I want to keep the P code generator and then compile from the P code generator to machine code. That will give me more meanings for debugging and for testing.
Good. Many thanks. I see some questions. Let me see from Jaco. Okay, time was short, but very interesting. Is it simil processor? Preprocessor? Yeah, maybe Jaco, you can unmute yourself and ask the
yes.
question.
Well, I maybe going to
Hi,
the
Dendo.
questions that I can read them myself.
Yeah, but I mean, he's in the call.
I mean, like PHP, a preprocessor, and after you compile to machine code.
I'm sorry, I didn't get it.
I was asking if it was a sort of preprocessor, text preprocessor, like PHP, and after you compile in machine code.
PHP is a little bit too large for. It stays a fun project, so I'm not really. I want to extend it maybe to a sort of small Pascal, but I never going to that far to make a real compiler of the size of PHP, or it's not really meant
No,
to work.
I mean, it was a sort of text preprocessor, like PHP. I don't know if you understand me.
You mean the approach is similar?
Yes.
Yeah.
Well, I really don't know how PHP just works, but I think PHP is on its same an interpreter, but I don't know.
Yeah,
But
yes,
in fact,
I mean,
it's the same principle of Java, for instance. Java is a compiler which codes to an intermediate code, and the intermediate code is interpreted by the Java virtual machine.
Okay,
so in fact, it's the same thing. It's the same thing that that I do here. It's not new. It's something Wirt did in the end of the in '68, I think. It's not new at all.
okay.
It's well, I can do everything and test it out in BASIC, so I don't have to. Well, when I make an error in generated machine code, the thing crashes. I have to load it again, and so was that your question?
Okay.
Yeah, yes. Then I see here, any plans for a compiler to support PET, VIC, or other platforms? Well, that was my last point in my slides. When it's finished, well, I can port it to other platforms. The only thing I have to do is just make a new virtual machine, or rewrite the code generator to the new machine, and it will work. Like, I think also to do it for an Arduino, for instance, or it will be possible. But for the moment, I stay on the 64.
Good, many thanks, Marc. I see as well comments from
You're
Dave
welcome.
actually on the Facebook page that he really enjoyed the presentation. Very good. I don't see any other questions. Is there any other questions? Anybody in the call? If not, then again, many thanks, Marc. I will then stop the recording now.